Sorry, there we go. All right, so hopefully that works now with the audio. I'm going to keep it on here just to make sure. But anyway, we're with non-interactive input, or with interactive input, you know, it was a prompt for input, and then you let the user sit there and mash their keyboard, hit enter, and then it reads that input, right? That was interactive. And then you went and you changed your program so that it was non-interactive, that you read in as command line arguments. There we go. Yeah, it works. All right, so that's because the vast majority of software out there is not written for end user human consumption, right? That's the tip of the iceberg that everybody sees and thinks what computing is. They see the nice, bright, shiny buttons in their apps and the games and stuff like that. The vast majority of actual running software is just to interact with other software. That's the whole point of software, right? You write software and programs to automate tasks so that you don't have to do the grunt work as humans anymore, right? Command line arguments are provided when you execute a program. For example, in C, when you execute your a.out, then the first one, and then the second one, and then the third one, they're all delimited by spaces, right? This example has 4 command line arguments because the executable file name in Java, in C, I should say, counts as the first argument. Because you could compile that file into a my awesome program, right, or my hello world program or something like that, your program is unaware of what it's called itself, and so that's why it's passed in as the first command line argument. The actual first user provided command line argument is at arg v sub 1, right? Arg c tells you how many the count of the number of arguments provided. Argv stands for vector. It's just a list. In this particular case, it's an array, and we'll get to arrays later on. But argv sub 0 is always going to be the executable file name, a.out in this case. Argv sub 1, argv sub 2, argv sub 3, and so on and so on. Right? Those are the actual arguments provided by the actual user. Hello, 10, 3.5. And as you can see, especially with hello, those are all strings. They're characters. They're not necessarily numbers. If you want to treat them as numbers, if you want to treat this as an integer 10 or this as a floating point 3.5, you need to convert them using either a to I or a to f. Hopefully you used a to f yesterday in your lab to convert, I don't know, what was it, width and height so you can compute a triangle or something like that, right? And if you pass in one of those arguments, argv sub 1, into a to I, it'll convert it into an integer. A to I stands for alphanumeric to integer. Right? It's a conversion. A to f stands for alphanumeric to floating point number, and it results in a double. What does that all look like in Java? Well, remember that we have that main args, right? It's all stored in one argument, args, right? There is no argc because in Java that's built into arrays. If you want to know how many arguments were actually passed, args.length gives you that. Okay. The first argument is actually the first user argument, not the class name. Why? Because in Java, if we create a class called demo, we know what it's called. It's in the code itself. So it's not a.out anymore. A.out is completely irrelevant because if you want the word demo, you've got it right here because you wrote the class. Right? So the first argument is actually the first argument. Args of 0 is going to be the first user provided argument. Difference between the two languages, the first argument and command line arguments. But you can do similar. If you want to convert, you can use double.parseDouble to convert it from a string into a double. Integer.parseInt to convert it to an integer. Right? Exact same as, say, a to I and a to f. Okay? Now what I want to do with probably the remainder of our day, I don't know, let's go ahead and create a brand new program from scratch. I'm going to call it quadratics.c. Right? So what's the very first thing that comes in any program is that author header. Right? And so me, yay, 2022, today is the, it's the last day of August. There we go. And now I'm going to describe to you what this program is going to be about. And we're going to work together here to actually write it, right? This program takes in coefficients a, b, and c of a quadratic polynomial, right? And here I can use some math, right? ax squared plus bx plus c equals 0, and computes the roots of the equation, right? The solutions to x using, you tell me, what do you use to solve that equation? Do I remember? Negative b plus minus square root 4ac, blah, 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 blah. Right? What is that called? Quadratic equation. Right? There we go. Using the quadratic equation. Use proper English there. Right? Now, some of those lines are getting kind of long, right? Old school guidelines would tell you that no line should be more than 72 characters. Right? And that style comes from a time when they had CRT monitors, right? Cathode ray tube monitors, where you only had 72 columns that you could actually print. So go down to the next line, go to the next line, or whatever. You can go ahead and go to the next line, right? Cut it off. You don't have to cut it off at 72, but keep it compact. That's nice. What comes next in C? So we understand what we're going to do, right? I'm going to ask the user for A, B, and C, and then we're going to use the quadratic equation, maybe some math, I don't know, to compute it. Yeah, go ahead. Say what? Standard libraries, right? I'm going to be doing standard stuff. Right? If I'm going to be doing input-output, I need standard input-output library. And if I'm going to be doing mathy stuff, I need the math library. Right? Square root sounds like math to me. Next is going to be my boilerplate main. Int main, int argc char star star argv. Return 0. Now you could pretty much take this code here without the comments, right? Without the comments of what it does, and put it over here, in a dummy template file, right? And then always, always cut and paste that whenever you do a program. We're going to get very quickly away from actual programs like this and start building actual libraries. So maybe that's not that useful, but for the first couple of weeks here, definitely. Right? Okay. So yeah, the audio was fixed. Thank you for commenting online. And I'll remind everybody that we are online, so if you have any questions, you can go to the YouTube live stream or to the to Piazza. So help me out here. Let's go with interactive input first. Right? What does that look like? I will prompt the user for A, right? Please enter A. Right? And then I'll scan F, right? Now, I want to read it into A. Right? Do I have an A yet? Nope. So let's go ahead and go back up here, right? And let's declare our variables. Should I make them all integers, A, B, and C? So are you always going to have integer coefficients here? Probably not, right? So what should I make? What type of variable should I make this? Double, right? Because you can have a 0.5 x squared, right? Or 1/2 x squared or something. Right? All right, I'm going to scan in A. Remind me, what is the placeholder in scanf for reading in a floating point number? LF, good. Now, is that correct? Let's go ahead and try to compile it, right? So this is a sanity check. Yeah, you write, especially in the beginning, you write a few lines of code, you compile it, you test it. You write a few lines of code, you compile it and test it. If you write 100 lines of code, right, and then you can try to compile it and test it, right, now you've got to go back and debug 100 lines of code. Whereas if you keep it small, in small chunks, and iteratively develop this and have sanity checks along the way, you're not going to have that huge problem of where is that bug, right? Yeah, go ahead.
Is it supposed to be a comma after the B?
Oh, thank you. Yep. And that's not even the error that I was intentionally making here. Thank you. All right, so what is the compiler going to complain about? Warning, LFA. For now, what is that magic thing that we put in front of variables when we're using scanf? Ampersand, right? There we go. All right, great. Well, I'm going to do the same for B and C, so copy, paste, paste. Please enter B, please enter C, please enter C. There we go. Right. Will it compile? Yeah. Right. Did I do it correctly?
You didn't fix B.
I didn't fix B, right? That's an artifact of me playing copy pasta, right? Copy paste, copy paste, copy paste. Call it copy pasta because it leads to spaghetti code. I even have a sticker of it down here. You can check it out after class, or maybe you can see it. I don't know. Stop spaghetti's code now, or something, right? Why is it what is spaghetti code? Well, think about cooked spaghetti, right? Uncooked spaghetti is nicely organized, right? All straight. But a cooked spaghetti, yeah, just on a dish or something, you can't tell where one noodle begins and where one noodle ends. Spaghetti code is similar. You can't tell where one line of code from another line of code because it's a huge mess. Right? And the way that you end up getting spaghetti code, one way you end up getting spaghetti code is by blindly copy paste, copy paste, copy paste, copy pasta. Right? Careful. Right? All right, so I've read in my 3 variables. Let's go ahead and have a sanity check to make sure that I actually read them incorrectly. Right? So the roots of %f x squared plus %f x plus %f. Why am I using %f again? We use %lf up there as scanf, but with printf you can use either, I think. Don't quote me. But %f is what I'll use generally. Right? R dot dot dot. Again, let's go ahead and compile it. It compiles fine. Great. A dot out. 10, 20, 30. 10, 20, 30 R. Okay. I'm convinced that it's working up to this point. Right? I'm iteratively testing it. Right? I'm iterating on it. Okay. So now let's actually go ahead and compute the roots. Help me out. Okay, I need a variable first of all to hold it, right? And it's probably going to be a double. What should I call it? Answer. Right. What does it represent? It represents a solution. It represents a root, right? Okay. Well, what's the first root? Negative. Quote me the quadratic equation. Hopefully, everybody you memorize that still, right? It's driven into you. No. No. Okay. Maybe not. Square root of b squared minus 4ac divided by 2a. Okay, great. Well, as the code markup there is telling me that this is all wrong, right? So there are several things that are wrong here. What's one thing that's wrong? Can I do 4ac like in algebra? Nope. Explicit multiplications everywhere. Right? Mathematically, is that sound? Do I have a numerator and a denominator proper? Nope. Numerator, denominator. There we go. All right. Another thing that you might ask yourself, well, wait, b squared. Can I do this? Nope. Some programming languages allow you to do that. In fact, that's the convention I used up here when I wrote the math. Right? C isn't one of them. That has a special meaning. It will compile. It will run. Right? Okay. It's going to give me an error. Okay, fine. If I had done it with integers, it probably would have been okay. Oh, no, the mixing of types is going to complain about that. It is a bitwise exclusive OR operator. Forget what that means until you get to, say, computer architecture. Right? All right, so some programming languages allow you to do something like this. I'm thinking Python allows you to do this. Right? That's going to be b raised to the power 2. Nope, can't do that in C. So one alternative is if you want to raise powers, pow is what you're looking for. Raise, and that's in the math library. Raise b to the power 2. So if you need to say pi raised to the power of 3.2, right? You can do arbitrary powers like that. Do I really need that sledgehammer solution for b squared? Oh, it's just b times b. Right? In fact, if the compiler will see pow b2, and it'll probably say you don't need that. You ain't gonna need that. Right? In fact, that's a common acronym that we'll talk about later. YAGNI. You ain't gonna need it, right? And so it compiles that away and optimizes that away. A simple multiplication is much better than that function call. Right? All right, is that the only root? Nope. So if I have two roots, what should I call them? Root 1, root 2, right? That's a violation of, in fact, these are bad variable names up here. A, B, C, root 1, root 2. But there's nothing better, right? Can you come up with something better? No. That's because this is just an abstract program, right? We're just doing some abstract mathematical ideas, right? And so in this particular instance, these variables are fine because I can't think of anything better. It would be like what? The first root of the equation, right? And go ahead and write an entire essay for your variable name. No. Keep it simple. Right? Simplicity trumps verbosity here. Okay. Now I will go ahead and print those, %f and %f. And I'll add that to the end of the line here. Yeah, go ahead. Thank you. The roots are different, aren't they? Minus. There we go. And you might be thinking, well, wait a second. We declared the variables up here. Why don't we go ahead and move these variable declarations up here? You can do that, but I like doing it like this stylistically because if you declare a variable up here and you're not using it until down here, right, then it's kind of separating the actual use of the variable from its declaration, right? Keep everything compact. You're using it down here, so go ahead and declare it down here. Now, the reason that you might see some people doing all of their variables up here is because that's an extremely old school way of doing it. We're talking about pre-1980s C, where you had pedantic C, where you had to create all of your variables up at the top of a function, right? We're fortunate in that they got rid of that really, really strict rule, right? Okay, this looks good. Let's go ahead and try it out. Uh-oh. I'm using math now, square root. Right? I need to compile with the math library. To do that, on some systems, you will need to provide an explicit flag to say, link the math library for me. -LM stands for link the math library, right? And it'll do it for you. If you want to know why it's that way, I can give you a CFAC link that you can read all about the history of why it's that way, right? It's because they thought, well, the standard math library is not really a standard. What if everybody wants to use their own math library? It turned out to be short-sighted and nobody wanted to rewrite the sign function, for example, right? So it should have been, but we're still living with that configuration today. Now, some different other configurations might do that automatically for you, but this particular GCC on VS Code is configured to, no, you have to use the -LM flag. Okay? And there's a reminder about that when you do your hack tomorrow. All right, let's run it. Please enter A. 2, 10, 4. Okay. Are those the roots? I don't know, right? Looks good to me. Is that a real test? Looks good? No. What would you have to do? Pull out your good old calculator, right? Compute the roots yourself and say, okay, yeah, that's right. Or bring a nice calculator here and what was it? 2, 10, 4. 2 roots of 2x squared plus 10x plus 4. There we go. And they're going to give you symbolic roots there. Right? So open that up, and you get actual numerical values here. 4, 5, 6, which is negative. That looks good. And 4, 3, 8, negative, which also looks good. Right? That's called ad hoc testing. Right? I'm just doing a really quick test, spot test to make sure, that a sanity test to make sure that it works. That is not a formal way of testing things. Later on, after the first exam, we'll get into informal unit testing and then formal unit testing with both languages. Well, with at least C. Right? Where you actually set up the actual tests and then automate those tests. When this runs, I should expect these two roots because I already calculated those using Wolfram Alpha. Right? So I've got an input, just like your grader actually. right? We've got input, and then we've got an expected output. And then we run it through your stuff, and we get your output. Do they match? If they do, then I put a 15 into the grade book for your lab, right? Or for your hacks or whatever. That's unit testing, right? All right, so works for me. Let's break it. Another form of testing is called fuzzing or chaos testing or something like that, where you try to get, you saw it yesterday when you tried to break the birthday program, right? So let's try to break this program. 0, 1, 1. What's going to happen? A is 0, yeah. Divide by 0, right? And we end up with nan and inf, right? So that's a corner case that we didn't take care of, right? All right, let's go ahead and run it again. How else could I break it? Negatives in the radical, so make B really small, make A and C really big, right? And I get not a number and not a number. Why? Square root of negative number is what? It's a complex number, right? But in computer science, it's going to be nan, not a number, right? Not a real number. There are a couple of other ways that you could probably break this, but that's good enough for now. When we get into conditionals, we'll come back to this and we'll fix it, right? By doing some defensive programming. Are we about to divide by 0? If so, we do something else. Are we about to compute a complex root? If so, we do something else. Yeah?
One of the optional activities on the lab yesterday, so you can validate the input data. How do you do that?
With conditionals. So for example, if I entered February 31st, right? Your conditional would be if the month is 2, February, and the day is greater than 28, or, and then you've got leap year logic, right? That's why it's going to get really complicated, right? If it's a leap year, then it can be 29, but if it's not, then it can't be 29, and that's what we mean by validation. You'd end up having to write at least a couple dozen lines of conditionals there to get everything absolutely correct. Right? And negative years are correct, right? It's just BC, right? But 1 through 12 for month, at most 1 through 31 for the day, and then you'd have to check the month, right? September has only 30 days, right? And so that's why it gets really complicated. That's why you end up using a library to do it, right? Because somebody already wrote that garbage. Right? All right, let's go ahead and get rid of this and change it to non-interactive input. So A, B, and C here are going to be read directly from the command line. A is equal to argv of 0, and now we're in C. Is that the first argument, actual argument? Nope. That's the command, that's a.out basically, the executable file name. Now is that going to work? What's it complaining about? You can't change it, a char star is a string. You can't change it from a string into a double automatically. You need to call a function to parse it out for you. What was that function? Alphanumeric to floating point number. There we go. Copy, paste, paste. Right? But you make absolutely sure that you change everything correctly. Right? There. Now what values did I use before? All right, so if I don't provide any command line arguments, here's a good question. What's going to happen? Segmentation fault. A segment is a segment of memory. And a fault means that I am trying to access memory that doesn't belong to me. And when that happens, the compiler or the operating system says, nope, that's a huge security risk, so I'm going to kill your program with a seg fault, a segmentation fault. Right? What was the problem? I didn't provide command line arguments, right? What would be nice? 10 to 10. B is small. That's too small. 2, 10, 2. There we go. Or what was it before? 2, 10, 4. There we go. And I get the same answers as before. Non-interactive input. But if I don't provide enough command line arguments, if I only provide, say, now how many am I actually providing there? 3 because of the executable file name. Segmentation fault, right? If I provide more, right, it ain't going to care about the other ones. It's only going to care about those 3 right there. So as a preview of what we're going to do eventually, maybe by the end of the day or certainly by Friday, is make some conditionals. If the number of arguments is not equal to what I expect, then I will do something else. This is a basic if statement, and then this is a truth statement. If argc, the number of the argument count, is not equal to 4 in this case, why 4? I need A, B, and C, but also that executable file name. If it's not equal to 4, then I will go ahead and say printf error, provide A, B, and C, and the line, and then I'll exit on them. And when I compile this and I don't provide those command line arguments, you see that it just errors out with an error message that says, nope, I expect 4 command line arguments here, or 3 user provided ones. And exiting means that I end up not computing or executing any of this code. I immediately exit. What does that 1 mean? It means it's an error code of 1. Non-zero error codes mean error. 0 means no error. We'll talk about that. Yeah.
Real quick, how do you make all those comments? Is there
Oh, you mean like comment out an entire block?
Yeah.
Like that? In both IDEs, it's going to be, well, for a Mac, it's going to be command /, just whatever the current selection is. And in Java, it's going to be the same thing. And on Windows, it's going to be HP control /. I'll leave that in there because I'm just going to post these as notes. But should I hand in my program with a bunch of commented out stuff? Nope, that's cruft. Remember? All right, cruft hall. We talked about cruft hall, right? All right, cruft. Get rid of your cruft. Right? Throw your stuff away, or better yet, recycle it. Don't recycle code though, right? If you recycle code, you're reusing code. I guess you do recycle code, right? Recycling is not the same thing as reusing. Right? All right, so I print an error message and then I exit out and I kill everything. Now, I'm showing this to you because in your very early programs, you do exit out when you can't do anything. If they don't provide me A, B, and C, there's no way that I can compute this stuff. So it makes sense to just exit out. Nope, please try again, user, right? But if you, when you start writing more sophisticated programs and you have function calling function, you never exit in those functions, right? Instead, you do something called error handling, and we'll talk about that later. Okay. Well, guess what? Copy, paste over here in a new class for Java. Let's translate it to Java. What should I call this? We call it quadratics.c in the C version. I'll go ahead and call it quadratics here, right? Now, why did I capitalize Q? That's the convention in Java. Java class names are upper camel cased. Is this a runnable program? Not without public static void main string args. And again, if I misspell it, it's not an executable program, right? It doesn't know what main is, right? Nothing happened, right? Min. Main, there we go. Now it's an executable program and nothing happens. Right? What it was running before was demo. Let me go ahead and close that so we don't get confused. Right? All right, well, let's translate this. Do I need to bring in a standard library? No, because, well, here, before we even start that, what should I do? Document, right? Do I need to change anything? Nope. All right, I've got a package declaration up here, of course. What libraries do I need to bring in? Do I need to bring in a standard library? No, because java.lang is already imported. Do I need to bring in a math library? You can, but you shouldn't. You're just going to go math dot on everything. But I am going to be doing, for at least for the first version, I am going to be doing interactive input. So what do I need? Scanner, right? And generally, you don't write the import statements. Instead, you let the IDE do it for you. I want a scanner, right? What I mean by that is, I just want a scanner down here. Scanner S is equal to new scanner that is going to scan the system.in standard input. And then I let it generate that code for me by point, click, done. Because I don't remember where it was. I do remember where it was, but you may not always remember, right? Java.util.scanner. Okay. Translated, translated, translated. Do I need any translation here? In fact, let me go ahead and just grab this entire chunk of code above the scanner. Nothing to change here. What's to change here, though? I don't have argc because do you see argc up here? Nope. Instead, in Java, what is argc? It's args.length. There we go. Now, should it be 4 in this case? Remember, the executable file name is not included because you named it quadratics. You know what it is. System.out.printf is the only thing I have to change there. Although it is a little bit better to use system.error, right? Because it's an error message. So there's input, there's output, and then there's the standard error output. And if you want to use that, that's fine too. The only difference here is, as far as Eclipse is concerned, is when something gets printed to the error, it's all red down here. Okay. Can I exit? Yeah, if you use system.exit. Okay. All right. Let's do the the interactive input first. Okay. Let's translate that. Oops. Okay, fine. So, how do I translate system.printf? Or I said it, system.printf. There we go. Or you can use println, or you can use print, whatever the case may be. I'm going to go ahead and go with printf here. I don't use scanf. Instead, what do? Well, now I need my scanner. My scanner needs to be up here now. A is equal to S, well, I named it S, dot, next double, copy, paste, paste, B, C, B, C. Cool. Translate these, computing the roots. What's the only translation I need? There is no square root. Instead, everything in Java is a class or belongs to a class. So I have to reference the math library. I didn't have to import it up here because the math library is part of java.lang and it's already automatically imported. You can do that, import java.lang.math if you really want to, but that's cruft, right? That's automatically done for you. It is superfluous code that should not be there. Okay. In writing, in creative writing, I'm not a creative writer at all, but I've heard the quote before that a great writer, it knows when they're done, not by adding things, but they know that they're done when there's nothing left to take away, right? So you know that you've got the perfect code if there's nothing left to take away, right? That's the absolute minimum. All right, and then system.out.printf. There. Run it. Oh, you know what? We want interactive input, so let me go ahead and get rid of that temporarily. What was it? 4, 10, 2. You'll see the green there. The green is the standard input. The black is the standard output, and if there were any standard error, it would be highlighted in red. I don't think that was the original, was it? 2, 10, 4. All right, run it again. 2, 10, 4. And those look like the numbers from before to me. Let's go ahead and uncomment this, comment out all of the interactive input. And now let's translate this, where we read it as command line arguments. Right? So we don't have A to F. Instead, what do we have? Double dot parse double. I don't want to write that 3 times. Magic. What did I do? I went into something called block selection mode. Mac, it's going to be Option Command A. Probably Control Shift A in Windows, I'm not sure. But what you can do is you can then select not line, but you can select blocks of code. And then you can start typing double dot parse double. Done. Cool? All right. Let's do it again. Not V, S. Done. Right. Little tricks like that you pick up, and then you realize years, like when you first see them, you go, I wish I'd known about this years ago, right? So if you know of any tricks like that I haven't learned in the 20 years or so that I've done it, please let me know and let everybody else know, right? Because if you've got little tricks like that, then you can get things done a hell of a lot quicker. Yeah.
How do you undo?
Control Z generally, right? So Control Z. That's most programs, though. Will undo. All right, let's run this. When I run it, it's going to, of course, say you didn't provide command line arguments here. How do I provide command line arguments when ostensibly there does not seem to be a command line here, right? There is just a console with output. You have what are called run configurations. So instead of hitting the play button, hit the down arrow next to it, run configurations. You go over to this tab called arguments, and you provide command line arguments. What were they again? 2, 10, and 4. You can apply it and save it, run it, and there you go, index 3 out of bounds. Oh, sorry. Okay. What did I screw up? Where's the first argument? 0, 1, 2. There we go. Run it again. Note I didn't have to re-enter those, right? To edit them, I would have to go down, run configurations, and then edit them again. But if you're going to reuse the same ones over and over again, then you can just go ahead and save it, and it'll run that run configuration again and again and again. Right. Questions? No? Okay. 10 minutes left. What about conditionals? Do we want to see some conditionals here to get us started for next time? All right, so let me go ahead and mark down, preview this, open. All right. So normal control flow in a program is linear, right? If you've got commands A, B, C, it'll execute A, B, C. Top to bottom, left to right, generally. Why? Because that's how we write in English, right? But more complex programs require you to make decisions, right? Both C and Java have basic if, else if, and if else if statements, right? And these are all these are the basic conditional statements. An if statement says, if this condition holds, do this thing. An if else statement says, if this condition holds, do this thing. If it doesn't, then do this other thing over there. 2 things instead of 1. And an if else if can be generalized to 50 different things, as if you want, although that sounds like bad code to me, right? 3 different conditions, 4 different conditions, 5 different conditions. You get up in any more than that, and you're probably wanting to look for a more sophisticated solution. Right? But each one relies on some sort of a logical condition, a Boolean statement that is either true or false. And note here that I am using the words true and false, but I'm not using any particular font there because they are, in C, you don't have those keywords. Right? You have those keywords if you bring in a library to do it. In Java, you do have those keywords, and they're all lowercase. Some programming languages don't have those keywords. Some programming languages use, for example, like Python. What is true and false in Python? Capital T, lowercase RUE, true. Capital F, ALSE, lowercase, are true and false, right? Some programming languages, it's all caps, true and false, right? But in Java we have those all lowercase, but in C we do not. Right? Here is the basic conditional for if and else if statements, like syntax, I should say. Some of you are probably already familiar with it, right? If some condition holds, now this is not real code, I am leaving this as a placeholder here. If some condition, then the code inside this block will execute if and only if the condition evaluates to true. There's no other thing. It's either true or false, right? It's not halfway true or halfway false or somewhere in between, right? Otherwise, if you can have an if-else statement. An if this condition holds and it's true, then we execute block A. Otherwise, if this condition is false, then we execute block B, right? Do we really have two different types of statements? Nope. Syntactically, look at what the first one is. If condition blah, it's just an empty else statement, right? What I could do instead is write this, else do nothing, right? And move on with your life with the rest of the program. Right? So there's not really two different things, if statements and if else statements. It's the same thing, it's just that you've chosen not to do the second part. Right? Really quick here, some examples to motivate us for next time here, right? What time is it? Yeah. Examples. Let me go ahead and jump in there. All right, there we go. I've set A equal to 0, I've set B equal to 10, and I've set C equal to 15. Here's how you can check for equality, right? If A is equal to 0, then I won't divide by 0, right? I'll have some defensive programming, just like our quadratic program here. If somebody entered an A, we could check for that as 0, and then prevent them from dividing by 0 down here and give them a different error message or something. Right? And you can check for equality of variables using the equals sign. Why do we have to use the equals sign? The single equals sign is already taken, right? As an assignment operator. There are some programming languages in which even that's not enough. And you need 3 equal signs, right? C is not one of them. Right? Python, not Python. PHP and JavaScript. That's what's called a strict equality testing. This is a loose equality testing. But in both languages, in both C and Java, this is equality testing. If A is 0, then we print this message. And then we move on with the rest of the program. Okay? You can also compare two variables, right? If A is equal to B, right? Printf, both variables are equal. Now, is this going to print or not? In this particular case, is A equal to B? Nope. Now it'll print, right? Okay. So you can make some comparisons between variables, variable values. What we say there is A is equal to, is A equal to 0, if A is equal to B, right? What you generally do, you could also do full expressions, of course, right? Let's not do those complex roots. B squared minus 4AC is less than 0. If that's the truth, if that's the case, then there are no real roots and we don't compute it, right? Okay. So, stylistically, we do not do the following. Here, I'll go into full code mode here. If A or 0 is equal to A, and then we do the same thing. Please do not divide by 0. There we go. Now that will compile and that will run. But does it look right? No. It doesn't look right for a reason. Listen to the plain old English sentence. if 0 is equal to A, then print this message. Does that sound right? Versus if A is equal to 0, then print this message. Which one of those two sentences sounds better? The second one, right? And so the second one, as far as code is concerned, is the one that you write. If you are comparing a variable to what's called the literal, an actual number, right? Then the literal goes on the left-hand side. There are exceptions that we'll look at later on stylistically just to make things work nicer. But otherwise, we generally do not do that. Right? We generally want to write code that sounds good when you read it in plain English. Right? All right, any questions? All right, have fun in your hack tomorrow then.